This is from the questions from periodic classification of the elements. So these are all the questions from the year 2008 CBSE exam. So question number 1. The elements of the second period of the periodic table are given below. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So give reason to explain why atomic radii decreases from lithium to the fluorine. Okay, so now they have asked you why the atomic radii decreases from lithium to fluorine. So what is meant by atomic radii? So it is defined as the distance between the nucleus and the outermost electrons. So now lithium, beryllium, boron, so all are in the same periods. So the electrons are added in the same shell. So the distance between the nucleus and the outermost electrons are not varying. And also the pulling of the electrons towards the nucleus will also increase. So it is because the nuclear charge increases. Yes. So what is meant by nuclear charge? The number of the protons which is present in the nucleus that will get increases by due to the increase in the atomic number. Say for example, the lithium is having a 3 and the boron is having a okay, so the lithium is having the 3 and the beryllium is having the 4. So the lithium is having the 3 protons and the beryllium is having the 4 protons. So the number of the nuclear charge increases, but the distance from the nucleus and the outermost shell electrons is decreasing, not decreasing, it remains the same throughout the same period. So the force of attraction between the nucleus and the valence electrons increases. So effective nuclear charge increases, hence the atomic radii decreases from lithium to the fluorine. The next question, identify the most metallic. Okay, so which one is the most metallic? Lithium, because the lithium is having one electron in the outermost shell, so it can easily lose it. So one which is losing, so that we call it as a metal. So lithium is the most metallic element. Non-metallic element, definitely the one which can able to gain electron fast. That means the electronegative character. So the non-metallic element is F because it can able to gain electrons easily. So due to the very smallest atomic size. Okay. Second question. So the elements of the third period of the periodic table are given below. So period 3, sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Okay. So the first question is, which atom is bigger, sodium or magnesium? Why? Okay. So now they are asking which atom is bigger. It's a sodium or magnesium. So sodium is bigger than the magnesium. Why? Because so the atomic sizes of the sodium is high because the distance between the nucleus and the outermost electrons is the same over here for the because it's having only the two shells. Magnesium is also having the two shells, but the effective nuclear charge increases, so there is a shrinking takes place, so the atomic size decreases. So because of that, the sodium has a bigger atom, lesser nuclear charge, so there is less force of attraction between the nucleus and the valence electrons, so there is a less effective nuclear charge, so it is therefore bigger in size. So the next one is the sodium is the okay, identify the most metallic. Yes, and the non-metallic element in the period 3. The most metallic is the sodium because it's having only one electron in the outermost shell, so it can easily lose the electron. So due to its larger atomic size. So the chlorine is the most non-metallic element because it can gain electrons easily due to its smallest atomic size. So next question. So the short answer type from the year 2008. So the next one is question 3. The position of the three elements A, B and C in the periodic table is shown below. Okay. So the group 16 we are having a B over here, C, A and C. Okay. Giving reasons, explain the following. Element A is a non-metal. Okay. So the A is a non-metal. Why? Because it can easily gain electron because it is present in the group 17. So it's having a 7 electrons in the outermost shell. So it needs 1 electron to complete the outermost shell. So it can easily gain the electrons. So 7 valence electrons. So it is easily form the negative ion. So one which is gaining, that we call it as a non-metal. So element A is the non-metal. Question number B. Element B has a large atomic size than the element C. Okay, so now the element C is having the large atomic size because the period is different. So this is present in the period 2 and this is present in the period 4. So once you are moving down the group, the number of the shells increases. So the compared to the A, the C is having the more number of the shells. It's because the B is having the lesser atomic number, so the less nuclear charge and the less force of attraction between the valence electrons and the nucleus, therefore it has the larger atomic size. Next one is element C has a valency of 1. Okay. Yeah, because the C is present in the group 17. It's having 7 electrons in the outermost shell. It needs one more electron to complete the a stable outermost configuration. So the valence electron is 7, so it needs one more. So it gained one electron to become the more stable. So its valency is equal to the 1. Next question. The position of the three elements A, B and C in the periodic table is shown below. Okay, so the group 1, the B is present, group 17, the A is present, group 16. Okay, element A is a non-metal. Yes, again the same answer because it's having the 7 electrons in the outermost shell, so it can easily gain the 1 electron, and so it is a non-metal. Atom of the element C has a larger size than the element A. Yes, so because as it is present in the period 2, it means that it's having only the 2 shells. So it's present in the period 3. So the period indicates always the number of the shells. So the C is having the 3 shells. So the distance from the nucleus and the outermost electrons increases over here. So that is why it's a larger in size than the element A. Next question. Element B has a valency of 1. Yes, so the element B is present in the group 1. So the group 1 indicates that always the group number 1 indicates that how many electrons are present in the outermost shell. So here it is 1. So the 1 electron is present in the outermost shell. So the element B can easily lose the 1 electron and it forms the stable configuration. So its valency is 1. Next question number 5. So what physical and chemical properties of the elements were used by the Mendeleev in creating his periodic table? List two observations which posed a challenge to the Mendeleev's periodic law. Okay. So the atomic mass. So yes, what is the atomic mass? The atomic mass is nothing but the combination of the protons and the neutrons which is present in the element. So it is a physical property and the nature and the formula of an oxide and the hydride formed. The chemical property was used by the Mendeleev. So the following are the two observations which posed a challenge to the Mendeleev's periodic law. So the increasing order of the atomic weights could not be maintained while matching the chemical properties. So the chemical properties do not depend upon the atomic masses. Yes, so what he has done over here is when the atomic weights are increasing, so he is not matched up with the chemical properties because it's changing. So that is the challenge which is faced by the Mendeleev. And one more thing is the isotopes have the different atomic mass but having the same chemical properties. Yes, because in those days the neutrons are not yet discovered. So that is why. So the isotopes means the what is meant by isotope? Isotope is nothing but same atomic number but different mass number. So the atom is having so say for example chlorine. Chlorine is having a atomic number 17, but the mass number we are having 35 and 37. So uh, because of the change in the neutrons, the different number of the neutrons. So the isotopes are having the same different atomic mass, but the same chemical properties. So this is the another challenge because the one of the what is that particle, the neutrons, which that time they have not yet discovered. So this is the two challenges faced by the Mendeleev. Next one is question number 6. Okay, so now here they have given some of the elements which is present in the periodic table. Okay, so the first question is, they have not given the first question itself. Okay, so the atomic size of the magnesium is less than that of the sodium. Yes, so magnesium is present in the group 2 and the sodium is present in the group 1. So because the magnesium is having the more effective nuclear charge, it's having the 12 protons and the sodium is having the 11 protons. So the attraction will be higher over there in the magnesium, but in the case the sodium is having the less attractive force, that is the less effective nuclear charge. So that's why the sodium is having a atomic size bigger than the magnesium. Fluorine is more reactive than the chlorine. Okay, fluorine is more reactive than the chlorine. Okay, the fluorine is present in the period 2 and the chlorine is present in the period 3. And also the atomic sizes decreases in the fluorine compared to that of the chlorine. The fluorine can easily form the F minus more easily than chlorine because of the smaller atomic size. So the F minus is more stable than the Cl minus. Therefore, the fluorine is more reactive than the chlorine. Question number 7. Why do we classify the elements? Okay, so now it is done so to study the properties of the elements conveniently. Yes. So for example, if I give you the group, suppose the element, if we know that what is the group and the period in which the element is present, so we can able to tell that how many number of the protons present, electrons, neutrons, and how many electrons are present in the outermost shell, what is the electronic configuration, what is its valency, whether it is a metal or the non-metal or the metalloid, whether it will lose the electron or gain the electron. So what is this property? Something we can able to save out. So that is why we are classifying the elements. Easy to study about the properties of the elements. Second question. What were the two criteria used by the Mendeleev in creating his periodic table? Yes. So increasing, yeah, he has used the increasing order of the atomic mass and the similar in the chemical properties. So these two things only he has used to arrange the elements in the periodic table. In the Mendeleev's, okay, why did Mendeleev leave some gaps in his periodic table? Because that gaps were left for the undiscovered elements. So all the elements were not discovered at those times. Only few elements were discovered. So wherever the place he has got it, similar chemical properties, he placed the elements in that space. So if it does not match or something, so he left some spaces for the undiscovered elements. In Mendeleev's periodic table, why was there no mention of the noble gases like helium, neon, argon? Yes, there is a no, they were nowhere mentioned in the Mendeleev periodic table for the noble gases because they have not invented at that time. Would you place the two isotopes chlorine Cl35 and Cl37 in the different slots because of their different atomic masses or in the same slot because their chemical properties are the same? Justify your answer. Okay, so actually we know that the Mendeleev used the two things. One is that based on that chemical properties, he classified the elements, and based on the um atomic mass, he classified. Now, in this case, the chlorine is having both are chlorine atom. Both are having a same chemical properties, but they are having a different mass. So they will keep it at the same slot because as they have the same chemical properties, according to the Mendeleev's periodic table. Okay, next one. So these are all the questions from the year 2009. So the first question: lithium, sodium, and potassium form a Dobberne's triad. The atomic masses of the lithium and the potassium are 7 and 39 respectively. So predict the atomic mass of the sodium. Okay. So now according to this Dobberner, so the lithium which is present before the sodium, potassium is present after the sodium. So he has taken the average of these two. So 7 plus 39 divided by the 2. So 46 divided by 2 gives 23. So 23 is the atomic mass of the sodium. Next question. Chlorine, bromine and iodine form a Dobberne's triad. The atomic masses of the chlorine and the iodine are 35.5 and 126.9 respectively. So predict the atomic masses of the bromine. So atomic masses of bromine is here also the same thing. So bromine, chlorine, bromine and the iodine. So what they have done is, so they have given the chlorine and the iodine atomic masses. So we have to predict the bromine. The same thing we have to follow. We have to take the average of these two. So 35.5 plus 126.9 divided by the 2. So 162.4 divided by 2, which gives 81.2. So this is the atomic mass of the bromine. Next question. Why was the system of the classification of elements into the triads not found suitable? Yes, it is because all the elements discovered at the time could not be classified into the triads. Okay, next, short answer type from the year 2009. State Mendeleev's periodic law. Write the two achievements of the Mendeleev's periodic table. So the Mendeleev's properties of the elements or the periodic functions of their atomic masses. Achievements, it could easily all the elements discovered at the time, and it helped also in the new elements. It also helped in the correction of the atomic masses of some of the elements. So these are all the achievements. So we can say that he has given some shape to the periodic table. So he would have given a very good periodic table because some of the elements are not yet discovered at the time. But he has done a very good job to make a periodic table. Then very short answer, 3 marks answer from the year 2009. So what is mean by the periodicity? So the repetition of the same properties after the definite interval is called the periodicity in the properties. So why do all the elements of the same group have the similar properties? Because they are having the same number of the outermost shell electrons. Whether it has to give one electron in all the elements, it has to lose only one electron. That's why. It is because the same valence electrons, therefore it's having the same properties. How will the tendency to gain electrons change as we go from left to right across a period Y? Okay, so the gaining of electrons from left to right. So the left we are having a metals, the right we are having the non-metals. So the left always losing the electron, the right always gaining the electron. Okay, so the tendency of gaining the electrons increases from left to right in a period because the atomic size goes on decreasing and the effective nuclear charge increases. Question number 13. So what are groups and the periods in the periodic table? Okay, so what are groups? The groups is nothing but the vertical column in the periodic table. So horizontal rows we call it as a period. Next one. The two elements M and N belong to the group 1 and the group 2 respectively and are in the same period of the periodic table. How do the following properties of the M and the N vary? Okay. So M and N are present in the group 1 and the group 2. So it means that M is having one electron in the outermost shell and N is having the two electrons in the outermost shell. Okay. Sizes of the atom. Okay. So now what will happen? M and N belong to the same period but the groups are different. That is group 1 and the group 2. So the N will be smaller compared to that of the M because the atomic size goes on decreasing when you are moving from left to right in the periodic table. Next one is their metallic character. So as we know that all the metals are placed in the left hand side of the periodic table. So once you are moving from left to right in the periodic table, so the metallic size decreases. So the sodium is more metallic character than the magnesium. So the next one is their valencies informing the oxides. Okay. So here the valency of the mm, M is 1 because it is present in the group 1 and N is 2 electrons, right? So the valency is increasing first and then decreases. So the valency is for the M is 1 and the N is 2. So it will start moving increasing from group 1 to 4, then it will start decreasing. Then the next question. Molecular formula of the chlorides. So molecular formula of the chlorides is so MCl because the chloride is having the -1 charge. So M is having the +1 charge. So +1 and the -1. So both the charges are the same. So you will be getting the MCl. So the next one is N. Okay. So N is present in the group 2. So it is having the +2 charge, but the chlorine is having only the -1 charge. So we need to add one more chloride ion to make the charges equal. So NCl2. So this is +2, this is -2. So these are all the molecular formulae of their chlorides. Next one is question number 14a. Which two criteria did Mendeleev use to classify the elements in the periodic table? So one is that atomic mass, the another one is the chemical property of the elements. So based on these two properties, so the Mendeleev classified the elements. State Mendeleev's periodic law. So the properties of the elements are the periodic functions of their atomic masses. Next question. Their valency, okay. Okay. So why could no fixed position be given to the hydrogen in the Mendeleev's period?
Hello,
Yeah.
ma'am. I believe we already covered this question in multiple short answer questions. I think, right?
Yeah, MCl, NCl2 are the
Yeah. Can we
formulas.
move on to the next question?
Yes, once again. This one?
Yeah, we also covered. I think this one also, second also.
Yeah. Okay, this one is not covered, right?
Yeah.
Okay. So this question is from the year 2010. The atoms of the 7 elements A, B, C, D, E, F, and G have a different number of electronic shells but have the same number of the electrons in the outermost shell. Okay, so it means that it's having the same group because it's having the same number of electrons in the outermost shell. The elements A and C combine with chlorine to form an acid and a common salt respectively. So the oxide of the element A is liquid at room temperature and is a neutral substance, while the oxides of the remaining six elements are basic in nature. So based on the above information, answer the following questions. What could be the element A, B? Okay. So now, will elements A to G belong to the same period or the same group of the periodic table? Okay, the first question is, what could be the element A? The element A can able to combine with the chlorine and it forms the acid. Okay, so always the metals can able to only forms the basic. The non-metals only will form the acidic in nature. And also the oxide of the element A is liquid at room temperature and is a neutral substance. But while the oxides of the remaining six elements are basic in nature, so it means that the metals are always forms the basic character and the non-metals are also having the acidic character, but this one is having the neutral one. So the element A will be the hydrogen because when it is combines with the oxygen, we are getting a liquid. And also one more the thing, it forms an acid. So it's a HCl, hydrochloric acid is formed. So based on these informations, we have found out the A is nothing but the hydrogen. Next question. Will elements A to G belong to the same period or the same group of the, okay. So now yeah, this we have already same number of electrons in the outermost shell. It means that it's a group. So it belongs to the same group of the periodic table having the same number of the valence electrons. Next question. So write the formula of the compound formed by the reaction of the write the formula of the compound formed by the reaction of the element A with the oxygen. Yes, that is H2O, right? Because the A is the element hydrogen. So when it is combining with the oxygen and it forms the A2O. So the formula of the compound, right? So it is A2. Show the formation of the compound by the combination of the element C with chlorine with the help of the electronic structure. Okay. So the formation of the compound by the combination of element C. So C is giving one electron because this present in the group 1 because the hydrogen is present in the group 1, so it's having a 1 electron in the valence shell. So the C is always, when you are moving down the group, the metallic character increases, so it will lose the electron easily. So the C, the element C can easily donate the electron, and the chlorine atom easily gains the electron and it forms the chloride ion. It forms the C plus and the Cl minus. So this is the ionic compound. So what would be the ratio of the number of combining atoms in a compound formed by the combination of the element A with the carbon? Okay, so element A with the carbon. Okay. Element A is having a 1 electron in the outermost shell, so it's having the valency is the 1. Carbon is having the valency is the 4. So we need to do the cross multiplication. So the ratio will be A4C. So that because the ratio is 4 is to 1. So what would be the ratio of the number of combining atoms in a compound formed by the combination of the element A with carbon? Okay, the ratio is 4 is to 1, so already we have given over here. Yeah. So which one of the given elements is likely to have the smallest atomic radius? So definitely the A is having the smallest atomic size because when we are moving down the group, the atomic size increases due to the increase in the number of the outermost shell. Okay, next question. Question number 17. So in the following table, the six elements A, B, C, D, E, and F of the modern periodic table with the atomic numbers 3 to 18 are given below. Okay. So which of these halogen is? a noble gas or a halogen. Okay, so they have given some of this, and so the G is present in the group 18. So this is present in the last column. So this we call it as a noble gas. So G is present in the last column, so it's a noble gas. So before that, it's a group 17. We call it as a halogen. So F is a halogen. F is a halogen, and G is the noble gas, because here all the electrons on the outermost shell are completely filled over here. If the B combines with F, what would be the formula of the compound? Okay, so the B is having a 1, F is having the 1, so 1 charge, so it forms the BF. Write the electronic configurations of the C and the E. So the C has the atomic number 12 and the electronic configuration is, so the first shell is K. So K will occupy the two electrons. The second shell we call it as L. So the L will occupy the 8 electrons. The third shell will occupy the 2 electrons. Then E has the atomic number 8 and the electronic configuration is, so the 2 will split up into 2, 6. So the first shell is K, so it will occupy the 2 electrons. The second shell is L, so it will occupy the 6 electrons. So in the following table are given 8 elements A, B, C, D, E, F, G and H of the modern periodic table with the atomic numbers of the elements in the parentheses. Okay. So now, what is the electronic configuration of the F? So the F is having the atomic number 12. So first 2 electrons we have to give in the first shell, then 8 electrons, then 2. So 2, 8, 2. What is the number of the valence electrons in the atom of F? So the valence electrons are nothing but how many number of the electrons which is present in the outermost shell. So it's having the configuration 2, 8, 2. So 2 is the valence electrons for the F. What is the number of the shells in the atom of the fluorine? So there are 3 shells in the F because the electrons occupied, this is in the first shell, second shell and third shell. So it contains the 3 shells. Write the size of the atoms of E, F, G and H in the decreasing order. Okay. So now we have to see where the E, F, G and H. So E is present in the group to E, F, G and H. Okay. So there will be increasing in the outermost shell for all the atoms. So H will have the more number of the size, then G, then F, then the E. So the decreasing order of the size of the atoms. Right, state whether the F is a metal or the non-metal. So as it is present in the group 17, so definitely the metallic size decreases from left to right in the periodic table. So the F, so in this case, the F is present in the group 1, so it is a metal. Out of the three elements, out of the three elements, one second. Yeah, out of the three elements B, E and F, which one has the biggest atomic size? Okay, B, E, F. So B, E, F. So which one is having the biggest atomic size? So B is having the biggest atomic size among the B, E and F. Because it is having it is present in the third period, so it is having the 3 shells. But the E is present in the group 2, it's having only the 2 shells. So compared to the E, the B is having the more number of the shells, so the atomic size increases. Then we have to compare the B and the F. So both are present in the same period. So it's having the same number of the shells. So it's having also 3 shells. This is also having the 3 shells. But in this case, the nuclear charges increases. In this case, it's less effective nuclear charge. So the pulling of the electron will be decreased over here. So it's having a bigger size.